Hello, my name is Arsha, and today I'm going to be critiquing a Java-based Python research paper. This is for the CS 4337 class, section 001. The title of this paper is Python and Java, the Best of Both Worlds, and the author is Jim Hu Yunin. So this paper was originally published in October 1997 by Jim, and it details building Python on top of Java as opposed to C. So Python is built on top of other languages, whether that be Java or C. And basically, in this article, he argues that Java-based Python provides many advantages over the traditional C base. So this paper is very credible. It was featured on Google Scholar with 79 citations. It was published in the proceedings of the Sixth International Python Conference, and the organization of the author is the Corporation for National Research Initiatives. So all of these are very reputable. So the benefits he argues for Java are portability, object-oriented nature, robustness and security, and finally glue friendliness. So first, portability. Java programs actually compile down to portable executable bytecodes. This is much different from C, as C requires a recompilation of source files, which is very complex. So if we look at this diagram, the user will pass in a source code or a program, which is a .java file. The compiler will read through and traverse the parse trees, converting it to bytecode, and this leads to a .class file, and then it requires the Java virtual machine to take that bytecode and convert it to machine code. Now, the JVM can be found on many different machines, whether that be Windows, Linux, or Mac. Um, and some of the further portable features are portable APIs, and those include data structures like queues, linked lists, hash maps, etc., and some sorting and algorithms like binary search, and of course like the arrays.sort, collections.source, input output tools like instream, outstream, and of course the scanner class, and then graphics, so any type of 3D graphics. It also has other options for like UI, like JOption pane, and all of these APIs are portable, whereas C kind of lacks this. So overall, C lacks the versatility and the versatile APIs that Java has, which makes portability of key APIs difficult for C. And this is a clear advantage of Java that gives the programmer more options. So then Java, of course, has object-oriented programming. And there's really, if of course we don't count abstraction, since that's found pretty much anywhere, and that's kind of encapsulated here. But the main parts of object-oriented programming are first inheritance, which is basically children classes inheriting from the parent. And this leads to code reuse. And here's an example. Say we have a vehicle class. Children of that vehicle class would be like an automobile class versus a pooled vehicle class. They're all vehicles, but they're a different type. And then the automobiles would be like cars and buses, whereas pooled vehicles would be like carts and rickshaws. And they would inherit certain things from the parent class, like vehicle, probably some kind of refuel, probably some kind of move with tires, something like that, that's common to the parent class. Next is encapsulation, and that's pretty much we have a program or a project and we encapsulate the details. So on the outside, we have a class. Inside of that class, we have methods, and inside of those methods, we have like variables. So we're encapsulating details. And finally, polymorphism. Polymorphism is basically when we inherit a method, but we like overload it. So the children class do their own implementation of it. An example is say all of these different animals like the cow, the bear, the bird, and the pig inherited the make noise method from an animal class. Well, although they're all inheriting the same like method structure, they're going to implement it differently to fit the animal. The cow would go moo, the bear would growl, the bird would chirp, and the pig would oink. And so overall, OOP is a very crucial programming concept that's difficult to implement in C, but is a clear advantage of Java. Furthermore, Java is very robust and secure. There's no segmentation faults for Java programs, and this leads to catchable runtime exceptions being thrown. And this can be controlled with like a try-catch block, which makes debugging a lot easier than doing that in C. And also, Java offers true garbage collection, so the reference counts are not required on the Python objects. And furthermore, it has circular references. So these will no longer lead to like a memory leak, which can be a security problem. Um, okay. Furthermore, Java is glue language friendly, which basically means that it's easier to automatically generate wrappers that allow Python programmers to like access the Java packages without needing to hand code them. Like you don't have to hand code the wrapper modules. And there's also a reflection API, which allows the glue languages to discover all methods and fields implemented by a given class and also allows them to be dynamically accessed during runtime. And that's a major advantage. So the author then explains the implementation of Python in Java. So the idea is how this author did it is he used the parser and elixir for the Python grammar. He used the compiler that was written in Python, and that would basically traverse the parse trees and convert them to bytecode. And then finally, he implemented a collection of Java-based support classes. These can be like input, output, some of the ones I mentioned earlier with certain data structures, algorithms, input, output features, etc. So the most important thing, of course, is the bytecode production. So there's a parse tree, which basically specifies like a language and it's traversed by the compiler. This is an example of a parse tree we have, and it's similar to what we've learned in class. So, once it does this traversing, there's some stack operations that need to be done, similar to the example we did like on the test. But the idea is that Python bytecodes and Java bytecodes actually look similar. These have certain similar functionality like adding, loading constants, etc. And basically, if we take the Python semantics and try to do Java bytecodes, we get some kind of hybrid in between. And that's what we kind of need with the compiler. Um, and so it's like an invoke virtual memory, for example. So once these bytecodes are produced, the JVM processes them and converts them to machine code. And then that's basically what the computer understands. That's like the commands the computer understands. So in order to actually do this, there needs to be like a Java class hierarchy for Python types. And this class hierarchy is basically we define Python types like PyInteger, PyString, PyDictionary as like their own classes. Like when you had like a vehicle class, an animal class, those were like types. The type of an object would be animal. In this case, we're doing the same thing, but with Python types. So the PyInteger is its own class, for example. And this leads to successful production of bytecode depending on the Python type. Um, and finally, the author had to deal with support classes, so he added these in, and it's really essential to increasing functionality, improving efficiency, and increasing writability of the language. And it uses or it incorporates data structures and algorithms like the stack shown here. It's similar to the C++ standard template library. And then, of course, input output tools and the scanner object. So we read in from a source with input stream, or we read data from a source. And if we want to write data to a destination, we use output stream. And then also the thread class, which is crucial in multi-threading and is really important for efficiency. That's part of the support classes. And the idea is basically we can run a task in parallel with different threads. And basically, it involves using stacks and registers, and it's similar to multiprocessing, but it's like a lightweight version of that. Um, so Java does introduce some complexities. Not everything that Java adds may necessarily be an advantage. For example, one of the complexities is that a separate Python frame stack is required for certain support code and to deal with certain like specific Python exceptions. Efficiency is also an issue. C is a more efficient language than Java. And then there's also additional complexities and potential exceptions to handle. So Java has like more exceptions due to the greater versatility and range of things you can do. So, so the author ended up testing this and found some results. So the author ended up running complicated Python modules to do various tasks. There was even an example of machine learning, which is normally done in Python because of like pandas and all of the tools like sklearn. And he ran these complicated modules on a traditional C-based foundation and then ran them on his Java-based Python basically. And the functionality was met. The results show that all requirements for the Python modules and the additional functionalities were met and successful. These included multi-threading. These included certain data structures. These included certain tasks for Python. There was, for example, matrix multiplication. That was a key part of it. And then again, the machine learning tasks. So, in terms of efficiency, though, there was an issue. The Python in Java implementation was about 1.7 times slower than the standard Python and C implementation. And this is again because C is a lower level language and it can be converted more easily to the machine code. And C is essentially more efficient because it doesn't or one of the reasons is it doesn't have all the functionality that Java does and all of the extra complexities. So, in summary, the article basically explained how Java has certain features that can make it an attractive option over C to use as like a Python basis. And this includes portability, object oriented programming, robustness, security, of course, the additional features, and high glue compatibility. And basically, the author implemented this by using a parser and a lexer for the Python grammar, similar to what we've been doing in class, a Python based compiler to basically traverse the parse trees and convert everything to bytecodes. And of course, adding in support classes for critical operations and tools. And these weren't these so the additional support classes weren't always like a requirement, but what they did is because of like the predefined code for those there was like improvements in efficiency which were an addition that helped improve performance. Now, the authors still mentioned that there were disadvantages of Java, which included the additional requirements for like the frame stack and overall lower efficiency than in C. That was like the biggest drawback. So, overall, this paper was very informative and easy to understand. It provided like relevant images, diagrams, and code snippets so you understood what was going on at each stage. And it was very procedural. It included like how implementation was done and followed it with testing. So it was very readable. It was organized into like multiple sections and subsections, which were easy to digest at one time. And furthermore, the author made sure to mention limitations of the experiment. So he said that he used the fastest virtual machine available, but acknowledged that over time, as advancements in computing occur, these results can change. And some of the other issues that he had were time issues and memory issues for the time. Memory back then was a lot more limited than it is now. And finally, the author used frequent like use of evidence to back his claims. He referred to other research papers and general knowledge, of course, and he even mentioned like specific companies like Microsoft, back then Sun, or which is now owned by Oracle. And future research was also discussed, like what he was working on specifically and what improvements could be made, like advancements in computing in general. Um, So my critiques of this paper overall were very positive, though I did have a few negatives. One was that the testing details and results could have been elaborated on. A statistical significance could have been mentioned, which I'm going to get to. Maybe like a graph could have been included. There should have been probably some more code snippets for certain topics, especially multi-threading. That would have helped a lot. There was again little discussion of the impact of multi-threading on efficiency. One of the critical problems with Python in general, the C-based version, is that there isn't like true multi-threading, whereas Java would offer that. So that definitely does have an impact on efficiency and should be mentioned. And then finally, this isn't really the author's fault. It's just that this paper was written over 2 decades ago, so some features and functionality of Java were not included in this, and certain computing advancements that were made recently were not mentioned. Also, other languages, like recent ones, could have been discussed, like the additions, of course, the C++, but like new languages like Julia, Dart, and Swift by Apple. So those could have been possible substitutes for Java, although they borrow a lot from Java. So that could have been discussed. So here's an example. This is a project I've done in the past where we really need to focus on statistical significance, and we can do this with like error bars. If they overlap, then there is not a significant difference from one to another. He could have done this with like various trials and like comparing efficiency, and this would have just led to like a little bit more credibility and a little bit more understanding of like how statistically significant the efficiency differences were. But overall, this is a very minor issue. So, in conclusion, this research paper was very understandable and informative. It emphasized with like empirical evidence the benefits of Java based Python, and it convinced me as a programmer that implementing Python in Java has a lot of benefits that can be super useful. Um, Now, of course, the advantages of Java are the main point that the author is making is that the advantages of Java are argue to outweigh those in the current C-based Python. And the author would implement all of this using basically the main three: Elixir parser, a compiler to convert the parse trees to bytecode, and finally the addition of the like helpful classes and files, or the additional like programs that would help in that, the support classes. So efficiency actually turned out to be the most prevalent issue, and that can be fixed through further research and development into processors and computing speeds. And furthermore, future Java updates can resolve some of the issues, such as the frame stack problem. And multi-threading is also a really good avenue that can be discussed further and can have a huge impact on efficiency. And then finally, as I said again, there are new languages coming out that are similar to Java and can be used as the basis for Python. So Python is a really high level language that's built on top of lower level ones. The more of these new languages, especially lower level ones that come out, the more opportunities to build Python on top of one of those. So overall, this is my critique, and I really enjoyed this assignment and learned a lot about Python's implementation. Thank you.